So good morning, everybody. Good afternoon if you're joining us from the East Coast. Thank you so much, everyone, for taking the time to meet us here. My name is Isaac Sorensen. I'm an architectural rep with W.R. Meadows in the Northeast, based in New York City. Thank you for joining us today for the basics of external concrete curing. Our presenter today is Ms. Taylor Wodzinski. Taylor is an architectural specialist that services parts of our Midwest territory. But before I pass the presentation over to her, let's go over a few things together. So everyone will be muted for the duration of the presentation. If you have questions, please type your questions into the Q&A box and double check that you are addressing your questions to all panelists. We will be monitoring the Q&A and we'll be attempting to answer your questions in real time. However, if your questions require a lengthier explanation or are a bit more complex, we may hold on to them until the end of the presentation to answer verbally, or we may need to get in touch with you afterward via email for a longer explanation. So this is an AIA accredited presentation. Everyone will receive certificates sent to the email address you provided to us at registration. And if you included your AIA number, we will also be submitting these credits directly to the AIA. So lastly, on the screen, you'll see an email address, info@wrmeadows.com. If you would like a copy of the presentation or would like to get in touch with your local Meadows rep or have additional questions for us in the future, please send us an email to info@wrmeadows.com, and we will certainly get you whatever you need. At this point, I'm going to turn over the presentation to Ms. Taylor Wodzinski. Taylor, take it away. Thank you so much for joining us today, everyone.
Thank you, Isaac. Good afternoon, everyone. My name is Taylor Wodzinski. I'm an architectural specialist that helps services the Midwest territory. I hope you're all doing well. On behalf of myself and W.R. Meadows, we would like to thank you for joining us today. Who would have thought back in March of 2020, we'd still be sitting here in front of our computers and doing most things virtually. Today, I will be presenting on the basics of external curing of concrete. Before I get into the actual presentation, I just want to give you a brief introduction of who we are and what we can offer to you. So a little background on W.R. Meadows. We were originally established in 1926 in Elgin, Illinois. Our corporate office now resides in Hampshire, Illinois. If you're unfamiliar with the area, this is right outside of Chicagoland. We are currently celebrating 95 years as a single-owned family company. We take great pride in being a family-owned company because not many manufacturers are family-owned anymore. We have now expanded to 13 facilities in North America and 2 in Canada. We do sell worldwide, which includes Europe, Middle East, Asia, and South America. We also have a sister company called Blue Ridge Fiberboard that sells sound dampening products. So these are the manufacturing and warehouse facilities in North America. So the yellow dots indicate our manufacturing facilities and the gray dots indicate our warehouses. We are here all over North America to help serve you. So W.R. Meadows designs, manufactures, and markets high-quality building materials for today's construction professionals. We originally started with the asphalt expansion joint, and we still manufacture it to today. We have now expanded our portfolio to 350 other products. So we have Division 3 products, which includes your expansion joint materials, concrete restoration, construction liquids, joint sealants, and decorative concrete. Also, we have a second section known as Division 7. You also hear it referred to as building envelope, which includes your vapor retarders, air, water, and vapor barriers, and waterproofing. So this presentation is an AIA and HSW accredited presentation. All registered architects are able to collect a learning point for today's presentation. You will receive certificates sent to the email address you provided to us at registration. If you supplied your AIA number, we will submit directly to the AIA on your behalf. So let's get into the basics of external curing of concrete. First things first, let's take a moment to acknowledge that in the built environment, a large portion of work will be accomplished by using concrete. whether that be for your structural support, longevity, relatively low cost, high strength, or for even ease of placement. There are many different ways, and it's an application that has become a relatively plentiful resource that has become a common and widely available building material. Much of what we build will be built with concrete in one form or another. Now let's define what external means. External curing is a step during construction that involves maintaining on the surface of your freshly placed concrete at adequate moisture and temperature conditions so it can develop properties such as your strength and durability. External curing is essentially a topical barrier to cure your concrete. It's not added into your mix design like internal curing. And at this point too, I should define what internal curing is. This is defined by American Concrete Institute, and it's defined by supplying water through a freshly placed cementitious mixture using your reservoirs via pre-wetted lightweight aggregates that readily release water as needed for your hydration or to replace moisture loss through the evaporation or self-desiccation. Today, we are going to talk primarily about the use of external curing of newly placed concrete. We will not be discussing internal curing. And throughout this presentation, you will hear me mention curing. This is only referring to externally. When we properly cure concrete, we end up reaching its maximum potential of strength, integrity, and longevity, and we actually set it up to perform optimally to its capabilities throughout its service life. In properly curing concrete, it's so important to pay close attention to its external surface area. And we can realize the greatest value of the substrate by ensuring it makes it safely through its earliest and most vulnerable phases. And this is going to be the first 28 days of its life. So let's start with some objectives for the class, and then we can get into the definitions that make up the components of curing concrete externally. Today's learning objectives is understanding the basic chemistry of concrete, defining external curing and the importance of external curing, choosing the correct product for your application, understanding the different methods of external curing, learning common specifying practices with reference standards and industry organizational references for curing best practices, and lastly, hot and cold weather concreting methods. So concrete is one of the most common construction materials used today. In fact, twice as much concrete is used in construction as all other building materials combined. It is also the second most consumed material in the world, water, of course, being your first. This means that 3 tons of concrete are used yearly for every single person. Concrete is also a composite material that consists of a mixture of hydraulic cement, aggregate, and water. This can be with or without admixtures, fibers, or other cementitious material. In order to understand our finished product, which is concrete, we need to understand the components that make up concrete in their basic form and how when they do combine, they end up forming concrete. So on this slide, we can see the components of concrete are made up of 3 basic building blocks: your cement powder, your water, and your aggregate. When they combine, they end up forming concrete. Portland cement is a powder and is considered a hydraulic cement, which means it needs water to set up to harden to gain strength. This is a very important building block. However, as I mentioned before, concrete is a composite and it can have other cementitious material that may or may not be hydraulic. So for an example, lime or gypsum is considered a non-hydraulic cement. And non-hydraulic means it does not need water to set. So when your cement reacts with your water, it then becomes a paste. And this process is also called hydration. And then when you add sand or a fine aggregate to your cement paste, you end up getting your mortar. And then when you add your coarse aggregate with your mortar, you end up with your finished product, which is concrete. As I mentioned in the slide before this one, concrete hardens by a process called hydration, and that's when your cement and water form a paste that coats your aggregate. This paste then will harden and gain strength. About 75% of Portland cement is composed of calcium silicates, and the rest is just a balance of compounds of your aluminum, iron, and gypsum. So during this reaction, calcium silicate reacts with water and forms calcium silicate hydrate, also known as CSH, and calcium hydroxide, also known as CH. There are other compounds that are being formed during this process, but for the sake of simplicity and understanding our concrete building blocks, We're going to call these the most important compounds that are being formed. So CSH is the most important of these as it contributes to setting, hardening, strength development, and volume stability. And CH contributes by providing an alkaline environment which is beneficial to your reinforcing steel. This is going to help with the reduction of potential for corrosion. In addition, there are other compounds such as your calcium aluminum hydrate and calcium ferrite that are being formed by hydration. And these also assist in maintaining the alkaline pH of your concrete, and it helps with that passiving layer around your structural steel. But when it comes to determining the strength of your concrete, the key factor is your water to cement ratio. That means mass ratio of water to your cement. A lower water cement ratio will yield a concrete which is stronger, while a higher water cement ratio yields a concrete with a lower strength. Water affects the workability and consistency of your concrete mix. To summarize all this information, remember it this way. Less water equals strong concrete. More water equals weaker concrete. Of course, though, this is left to our mix design engineers to determine the exact and correct amount of water for the desired strength to create your perfect concrete. It's also important to remember that water can affect our concrete, and we can assume that if we add more or less water, we will be affecting our concrete. We've all heard the terms of HPC, which is known as high performance concrete, and UHPC is ultra high performance concrete. To reiterate, one of the properties to get high strength is by using a low amount of water or having a low water to cement ratio. Here's an animation of the way that the hydration of your concrete creates these CSH crystals that start to form. So think of them as they're reaching out and grabbing the rock or aggregate to incorporate everything into your mix. And this is going to become one solid formation. You'll see in the following slide, as the crystals start to form, reach out and latch and grab onto the aggregate. The crystals then start to thin and delicate with lots of capillary space in between them. Then in the following slide, you'll see how the crystal becomes a real solid, a fully formed mass incorporating your aggregate. So this is the magnified picture of your actual crystals that start to emerge from your cement. And this is the magnified picture of your completed hydration cycle that we talked about. So at this point, the crystals have completed their growth cycle and grabbed onto the aggregate. Now let's consider if we're curing concrete on a hot day and enough of our water ends up evaporating, or if we don't add the correct amount of water to our mix and we fall short for what is needed for the hydration process to take place, we immediately are adding many negative characteristics to our concrete that has just been placed. And these are just several of the negative effects that could occur, whether that be your severe strength loss, thermal cracking, and thermal cracking is when cracks from your concrete cure too quickly, or even hair checking, which is very fine surface cracks that create a weak surface. Or you could also run into the problems of shrinkage cracks and surface scaling. And this slide serves as an illustration of how the strength or compressive strength of our concrete is affected by more or less water added to our mix, and how if we don't add just the right amount of hydration, or if our concrete loses too much water in the curing process, the hydration reaction stops, and we end up losing the desired strength and performance for our concrete. So there are many ways in which we can avoid all the concrete problems described up to this point by properly external curing of concrete. This is described by American Concrete Institute. ACI defines concrete curing by the action taken by a contractor to maintain the moisture and temperature conditions in freshly placed concrete. So for the purpose of this definition, I should mention what a pozzolan is. And think of pozzolans as a broad class of silicous or silicous and luminous materials which in themselves actually possess no cementitious value. But in finely divided form and within the presence of water, it's going to react chemically with the calcium hydroxide at ordinary temperatures to form compounds. And this is going to give you what possesses cementitious properties. The general definition of a pozzolan embraces a large number of materials which vary widely in terms of your origin, composition, and properties. So this can be both natural and artificial, so man-made, and they're going to show pozzolanic activity, and they're used as supplementary cementitious materials. A perfect example of what a pozzolan would be is considered fly ash. As described on this slide, external curing has a significant influence on all properties of hardened concrete. All of these characteristics like abrasion resistance, volume stability, and permeability will create your perfect concrete if realized and optimized by care by properly addressing external curing. Now let's get into some of the ways we can approach proper external curing of concrete. You can see here in the first example, we prevent moisture loss by using a physical barrier by placing plastic sheathing. Sometimes this isn't enough if we are in high heat and direct sunlight. This method works best in lower temperatures and cooler regions. We can also use curing blankets or even liquid curing compounds. We'll talk about those in greater detail in some of my further slides. Another way to externally cure is by adding extra moisture by fogging or ponding, so that your moisture is actually on top of your slab, or you could add water-saturated burlap to your surface. And the burlap method is one of the most widely used around the globes. This method is most commonly used in second and third world countries where cost-effective methods take first place. We can also externally cure by supplying heat and additional moisture with electric blankets or other forms of heat where moisture loss will happen in the absence of extra heat. All these methods can be effective depending on the temperature and your expected climate conditions. So immersion by ponding with water is what is shown here. Water curing of concrete is an effective curing method for preventing mixed water evaporation. It's going to fill all of your requirements for your hydration for your concrete, and it helps with the elimination of shrinkage. It is also effective for maintaining a uniform temperature throughout your concrete. There are some downsides, like with anything, like your limited access to being able to keep your slab saturated with water. And most importantly, what do you do with all that remaining water? And lastly, it is a very costly method. As I mentioned before, adding wet burlap to cover your surface of your concrete is one of the most widely used methods around the world. It's a quick and cost-effective method. In the hot sun and the concrete hydration creating surface heat, your burlap can lose water quickly if it is not regularly kept saturated with water. The burlap can dry out and actually wick away the moisture from your surface, which is not good for good curing. So this method works, but your burlap has to be tended to and maintain its water saturation. As you can see in this photo, they are placing dry burlap down. That burlap needs to be kept continuously wet to be effective. So plastic sheets can be applied on thoroughly wet concrete, such as your polyethylene film. This material is a lightweight, effective moisture retarder that is easy to apply. During placement, though, the concrete surface should be hard enough to prevent surface damage. There are some downsides to curing with plastic sheathing, and one of them being the surface profile that is left by the plastic on your surface, which in many cases is undesirable and will lead to extra labor to amend. Plastic sheathing can discolor your concrete with uneven moisture retention that is retained under the plastic, likely with pooling or ponding in different areas, while other areas under your sheet could completely dry out. This can lead to blotchy or discoloration, and in most cases, your concrete needs to be protected against freezing conditions. Your concrete can retain moisture, and the plastic sheathing will not properly insulate against freezing conditions. So in this photo, do you notice all of the large white areas? This is referred to as tenting. Those areas might likely be lighter because the sheet isn't bonded to the concrete currently. Now let's take a step back and talk about some of the methods we have learned for curing and discuss how they are specified. Remember that if we don't specify the external curing method properly, we may be left with a less than desirable piece of concrete at the end of the day. As we had discussed earlier, if you're going to go with a sheet material and would like to specify that, ASTM C1315 will help by ensuring the material specified will work for externally curing concrete. This is going to have a low water vapor transmission rate, and you're going to have no more than 10 grams per square meter at 24 hours, as described by ASTM C171 specification. Following the last slide, we can see what is encompassed within ASTM C171 specification. ASTM E96 water vapor transmission we just discussed. Now let's discuss ASTM E1347. And this states the daylight reflectance of the white side of your white paper shall be at least 50% when measured by test method ASTM E1347. The daylight reflectance of your white polyethylene film and the polyethylene side of your white burlap, your polyethylene sheet shall be at least 70% when measured to test method ASTM E1347. So the daylight reflectance is used in effort to reduce excessive heat temperatures on your surface. So reducing heat will actually lead to stronger concrete in the end. The most economical way to cure a slab of concrete is to use curing compounds. As we will learn in further slides, curing compounds take many different and varied forms. So we're going to start with the first one, which is dissipating cures. Dissipating cures are often used in these types of applications, whether that be your DOT applications, driveways, or even for sidewalks. They are called dissipating because the membrane will begin to chemically break down under UV exposure after 4 to 6 weeks, and eventually it's going to dissipate from your surface. This process is sped up under normal traffic, UV exposure, and weathering conditions though. So your paint, tile, and resilient flooring can be applied at a later point. Dissipating cures, simply explained, are that they will dissipate or disappear through surface wear and time exposed to outdoor conditions. And eventually you are left with a clean and perfectly cured concrete application. Dissipating cures are used in exterior applications most widely and are relatively inexpensive. Now let's talk about liquid membrane curing compounds. The nice thing about them is that they're liquids that are sprayed directly onto the surface of your concrete, and then they're allowed to dry, and that is going to retard or reduce the moisture loss from your concrete substrate. The most effective way to specify this is based on ASTM C309 specification and ASTM C1315 specification, one tested per ASTM C156. So curing compounds or cures, they are known as liquid membrane forming compounds. When applied to fresh concrete, it's going to reduce moisture loss in the early hardening period. A curing compound helps retain moisture in your concrete, which actually results in an improved hydration of your concrete. This improved hydration produces a stronger and denser concrete substrate when compared to improperly or uncured concrete. Their curing compound is considered a temporary coating, which means it will eventually break down and dissipate from your UV light and traffic. Now let's dive a little bit deeper and try to make sense of all of this information. Ultimately, our goal is to define what our cured concrete will be used for during its surface life and specify the correct liquid membrane and its associated characteristics. We need to find a specification that covers our needs and doesn't harm the possibility of, let's say, putting a floor covering on top of it or making sure that its surface stays relatively blemish-free and monochromatic without blotching if we're going to leave it exposed for a natural finished concrete look. There are many different types of liquid membrane curing compounds, so it's really important to pay close attention to how they are categorized as we dive into differentiating one from another and how to specify them and be able to tell them apart. Let's start with the first, which is ASTM C309. As you can see from this chart, ASTM C309 specification comes with a type, whether that be 1, 1D, and type 2, and a classification, Class A or Class B. Both of these need to be mentioned when specifying them within your specifications. So when you're picking a type, it's important to consider your application and whether or not you will need a fugitive dye or if a clear coat will suffice. A fugitive dye helps when applying your membrane to keep track of where it has been sprayed, as it shows for a minimal period of time, and then it's going to disappear within a few hours. If you're doing a driveway or a sidewalk outside of a residential building and you have multiple areas and days of work ahead, a fugitive dye can be extremely helpful in keeping track of where you already applied your membrane. But be careful in specifying a white pigmented or a type 2 product around outdoor areas adjacent to your indoor construction, as your pigment can be tracked indoors with your boots and then damage or stain finishes in undesirable areas of your construction. Generally, type 2 is reserved for industrial projects away from residential work. So in commercial work highway roads and large outdoor projects, you will most certainly need to use a type 2 product because of its UV reflectance and its ease of understanding where the membrane has been placed, as a fugitive dye will not be sufficient in quickly identifying your areas that have been sprayed. Another rule of thumb with type 2 is that it needs sufficient wear and outdoor exposure to actually dissipate. If you were to use this at an indoor warehouse with minimal traffic, the pigment may stay on your surface and not be broken down and dissipate in a desirable period of time, or it's going to leave you an opportunity to add other treatments and coverings to your surface. As far as class goes, the class refers to the solids within your material. So class A refers to unrestricted, and this can be your wax, your clay, or really any type of solid. And your Class B refers to the restricted classes of hydrocarbon resin carriers. So a good general rule of thumb for ASTM C309 is that they can be dissipating cures. It has to be placed on fresh concrete. It can be clear, transparent, or pigmented, and typically it's not going to be used on architectural finishes. For an example to how they are specified, ASTM C309 Type 2 Class A and B means the product is resin-based and white pigmented. So now let's look at the performance requirements that make up ASTM C309 specification and discuss that. As you can see from this chart, there are a number of desirable ASTM performance specifications that are contained within ASTM C309 specification that will assist greatly in the placement performance of your specified liquid curing compound. You're going to receive that minimal moisture loss, the adequate UV reflectance, the correct drying time, and the ease of being able to spray the product in order to put it down quickly, evenly, and easily. So these are the performance requirements that are contained within ASTM C309 specification. So ASTM C309 is the older and less restrictive, and typically it applies to curing agents used for highway work or bridge decks. Now that we've looked at ASTM C309 specification, let's take a look at the next spec of a liquid membrane curing compound. So think of these as the added feature of a built-in sealer. These products are known as cures and seals, and ASTM C1315 encompasses them. We'll learn a little bit more about what a sealer is a little further into my presentation. But for now, think of the sealer as an enhancement or added aesthetic and performance value to the surface of your concrete. These products contain even more performance requirements, positive attributes, and it really builds upon the ASTM C309 specification by adding some additional types and classes of performance. Generally, we can understand the ASTM C1315 specification to be a little bit more specific to the application. It has two types and three classes. The type, as you can see, refers to the way the products are pigmented or clear and translucent, and the class refers to the UV light will change them over time. In this photo, this is a perfect example of UV degradation, and Class A is shown on the left and Class B is shown on the right. As you can see, Class B products really don't age well over time. And at this point, I should mention more about what a cure and seal is. So the cure portion of the name means it can be used as a liquid curing membrane for concrete. This material must be able to form a film on the surface of your fresh concrete, and what it's going to do, it's going to hold in only a portion of the mixed water to aid in that cement hydration process we talked about. That remaining unused water is then allowed to evaporate through the membrane at a controlled rate. Without this process, your design strength might not be developed. The seal portion in this name means it functions as a sealer. As a sealer, it protects the concrete for a period of time. Curing and sealing concrete are different processes and are performed at different times in the life of your concrete. These are the performance requirements of ASTM C1315, and it should become quickly apparent that it is a more stringent specification than ASTM C309. It has a 25% minimum solids requirement. It has a 0.4 maximum moisture loss requirement. It has a 65% minimum reflectance requirement. It has a UV degradation and yellowing after 2 weeks requirement. It has an alkali and acid resistance requirement. And then finally, an adhesion requirement. So this slide serves as a comparison chart to understand how these two very important specifications for external curing of concrete. As I mentioned, ASTM C309 has no solids requirement. However, ASTM C1315 has a 25% minimum. Higher percent solids material, though, can be extremely difficult to deal with. Your contractor needs to be educated enough on using the right sprayer and right tip. Another thing, ASTM C1315 has a much lower moisture loss requirement. ASTM C1315 has a higher reflectance percent. ASTM C1315 has a UV degradation, alkali and acid resistance, and adhesion requirement. All in all, ASTM C1315 is a more stringent requirement than ASTM C309. This is a perfect opportunity for you to take a quick snippet. This is going to give you a general rule of thumb for what cure is best for what type of application. Now let's discuss more about a curing and sealing compound, or known as cures and seals. As I had outlined earlier, they form a film that offers continued protection, approved aesthetic qualities such as your shine, gloss, or even that wet look surface to your concrete. Curing and sealing compounds are designed to be used on fresh concrete to cure, and then will also remain on your concrete to offer the additional benefits of a sealer, adding improved appearance or improved resistance to chemicals, water intrusion, and de-icing of salts. At this point too, I want to mention industrial warehouse floors because technically we have them marked for dissipating cures. And technically you could use a dissipating cure indoors. However, as I mentioned before, you need proper UV light and traffic to dissipate your membrane. These do not have the sealer component, and they will wear away or dissipate over time. Here is the real takeaway from this slide. No method is optimal for use in all situations. Choose your curing method based on the purpose of your concrete, any subsequent treatment, coating, finish it will receive, and the environment in which the work is going to be done in. And lastly, please confirm with your manufacturer rep to confirm the product is correct for your type of application. So I think it's important to take a step back and understand, is it a specification? Is it a test method, or is it a guide? And we have discussed a lot about them, and it's important to understand the differences. A specification has performance requirements. A test method tells us how to perform the test. So within a specification, there's going to be test methods outlined to tell us how to do the test. And finally, a guide. A guide is for recommendation use only. There won't be a specification requirement. It's only guiding us on how to recommend to do the application. So a new trend of the concrete industry is non-film forming curing agents. It meets the moisture retention requirements of your ASTM C309 on hard trialed concrete, but it does not meet the full ASTM C309 specification because it is not a film forming cure. It is a penetrating product that's going to react with the calcium hydroxide to form a calcium silicate hydrate reaction. So this actually would be a great application for a warehouse floor or even a second story slab that has already been installed. What kind of floor do you require on your project? The main idea for answering this question is to specify correctly the right type of product to meet your project requirements as they relate to flooring or surface preparation and coverings before, during, or after your concrete has been properly cured. It's really important to consider the big picture here. What will you be applying subsequently? And will it be compatible with what you are applying? And finally, will it need to be removed? Another very important consideration in the proper curing of external concrete is the weather that the project will be taking place in. The necessary precautions and curing methods must be undertaken as American Concrete Institute has laid them out in depth for us under ACI 305 and ACI 306 guidance. In order not to get extremely technical, but to understand some of the basic precautions, let's discuss for a moment cold and hot weather concrete curing. Referring to ACI 306R, cold weather concrete guidance should be applied when your air temperature is below 40 degrees or is to be expected to be below 40 degrees during your protection period. So the protection period is the time between 1 and 4 days for your concrete with accelerators mixed in. As we had talked about earlier slides, there is plenty of old and new technology and ways to cure concrete in cold weather. This can be electricity to create warmth in extreme temperatures and multiple forms of insulating. But in depth, this process is best laid out by ACI and it should be followed. So ACI 305R does not provide maximum temperatures guidance for concrete placement during hot weather. The real emphasis on this guide is being able to maintain proper workability without affecting your concrete strength. During hot weather, the rate of your cement hydration increases as your evaporation creates issues with the workability of your concrete. The addition of the water to your mix would typically mitigate these issues, but because unfortunately additional water reduces your concrete strength and increases shrinkage, which then causes cracking. Building on the guidance of ACI 305R, our next slide really helps us make decisions about the application. For hot weather applications, as I had outlined a little bit ago, we are going to experience a lot of negative attributes and quickly after our placement if not followed the guidance of ACI 305R. This next slide really helps us better understand by charting the high temperature, relative humidity, and wind speed to help us gain a better understanding of how to avoid these negative attributes from hot weather concreting. So this is our NRMCA-PCA Nomograph. So the air temperature, relative humidity, and wind speed affect greatly the rate of your evaporation of your surface moisture from concrete in hot weather. But there are other applications at lower temperatures, but most notably, this chart is very helpful in hot weather applications. This chart provides a graphic method of estimating the loss of your surface moisture for various weather conditions. In order to use this chart, you're going to need to follow the 4 steps outlined in this figure. I should mention, if the rate of your evaporation approaches the 0.2 pounds square feet per hours, your precautions against plastic shrinkage cracking are necessary. So in order to use this chart, go to step 1. You're going to enter with your air temperature and move up to relative humidity. Step 2, you're going to move right to your concrete temperature. Step 3, you're going to move down to wind velocity. And finally, step 4, you're going to move left and read your approximate rate of evaporation. I just want to quickly reiterate, evaporation retarders are not curing compounds. Evaporation retarders are products that can be found within these categories and even grouped into my presentation, but it cannot be defined as a curing compound or sealer. They help with maintaining the surface moisture on your concrete floors, slabs, and repairs in extreme and inclement weather conditions. So try to think of this as a transitional step prior to your curing. It's not to be used as a finishing aid. It's a supplement where the evaporation rate exceeds the rate of your bleeding. And bleeding refers to the process where free water in your mix is actually pushed upward due to the surface, due to the settlement of your heavier solid particles. And this is going to be from your cement and your water. So some bleeding is normal, however, excessive bleeding is problematic. In summary, external curing of concrete is critical to long-term performance. Improper and insufficient external curing methods will negatively affect the performance of your concrete. Please try to understand the standards and references to be able to specify them within your specifications. And lastly, consider the design and installation of these materials when dealing with hot and cold weather applications. This is just another opportunity for you to take a quick snippet. These are the references that I used without my presentation. This would also be a good opportunity for you to mention them within your specifications. This concludes the AIA portion of my presentation. Thank you for your time, and I appreciate each of you taking time out of your day to be with me. We would love to be a resource for your construction liquid needs. And please consider viewing our website for CAD details, installation instructions, and project profiles. We honestly just have an endless supply of information available on our website. Now, can we address any questions?
Thank you so much, Taylor. This is Isaac again. Thank you. Very excellent job. Thank you, everybody, for attending. We have a couple of minutes now to answer questions. First of all, we did receive a couple of questions regarding how to obtain our presentation. And as mentioned earlier, the simplest way to do that would be to shoot us an email at info@wrmeadows.com. This presentation will be available on YouTube as well within the next couple of days. So I'm going to start out with some of the questions that we got for Taylor. Taylor, we got one that says, can I remove the dissipating cures before they fully dissipate?
This is a really great question and a common question that I receive. And the answer is yes, you can use chemical or mechanical means to remove. So for chemical, you're going to either use a degreaser or stripper. And for mechanical, you're going to use water blasting.
Excellent. Thank you so much. There's a few more here I'm going to get into. Why did the cure and seal turn white that I was using? Was another question. I hope that's clear enough.
Um, I think the best way to answer this question is to break it into two different parts. So that's going to be cause and prevention. So please keep in mind though, this is a general guide to troubleshoot your problems. So the cause, it sounds like your product was applied too heavily, or there are too many coats of sealer that's currently on your concrete. So what happens is moisture is now trapped underneath your sealer and it has caused it to lose adhesion from your concrete. So the prevention of this would be follow your manufacturer's recommended coverage rates. I hope that answers it.
I think so. That's pretty clear. We have another here. I used the cure and seal material. Do I need to remove this prior to my flooring?
Typically, it needs to be removed. However, we will recommend that you consult with your flooring manufacturers because they are the ones that are actually providing the warranties. As I mentioned throughout my presentation, this would actually be a perfect application for a non-film forming curing agent.
Excellent. Yeah, and I would mention as well, of course, it's very important what type of floor covering you're using in that instance, but generally, um, yeah, that makes perfect sense. Uh, Another question here. Can I use a white pigmented cure on a residential driveway?
Um, I would not actually recommend it. You can track pigment on your boots or other things in undesirable areas. We would recommend a form filming cure and seal or a form filming cure, of course, except type 2 products. A non-film forming curing agent, even too, that'd be beneficial as well. As I had mentioned to you within my presentation, with the slide of thinking a big picture, this would actually apply to that. So what will you be applying subsequently, and will it need to be compatible with what you are applying?
Excellent. Pretty straightforward there. We have another question here. Why is the cure and seal peeling off or flaking on my project?
So same situation, I'm going to do cause and prevention. The cause sounds like it's a product that has been applied too heavily again, or there are too many coats of sealer on your concrete currently, or even possibility that your concrete was not prepared properly before its application. Since concrete cures and seal products typically last 1 to 3 years, some peeling and flaking is normal as your product actually begins to wear away. especially in areas of your high traffic or direct sunlight. So the prevention would be, again, is to follow your manufacturer's recommended coverage rates and its preparation methods.
Excellent. Well, thank you for those answers. We have a few more questions here. One random that we may be able to answer right now, and then another that I will probably have to get back to the questioner, Ron B, after the presentation. But we'll finish with this last question: is how is the temperature of concrete determined? And Taylor, if you want to give a crack at that, if not, you can pass it back to me, and we'll make sure that that question gets answered by the asker in a private setting.
Isaac, if you would like to answer that, by all means, but this may be a question we need to get with that person after this to be able to further discuss.
Yeah, I mean, generally, it kind of depends what we're talking about. Are we talking about the temperature of concrete during placement? The ambient temperature in the air, of course, is very important when you are placing your concrete to determine what type of steps you're going to take. I think that's what they're getting at. In any case, the ambient temperature that you're placing your concrete in is very important. But the temperature of the concrete itself can be determined by the mixer of the concrete as it's coming up to temperature before full hydration. I think we should probably answer this in a private setting and get a little clearer on what they are asking. And I think that's it for the public portion of this presentation. I do thank all of you that were able to join us today. Again, recommendation to reach out to us at info@wrmeadows.com if you are interested in getting a copy of the presentation or if you have further questions for us. I would also encourage you to spend some time on our website, www.wrmeadows.com. We have a multitude of information for architects and engineers, designers, any of you contractors that are spending time with our building products. We would recommend you to go there and spend some time on the site. It is very easily navigable, and there's a lot of resources available for you, from CAD details, data sheets, full submittal downloads, lots of different information there that you would require for your projects. And if not, if you're interested in getting quick answers and you'd like your local rep to reach out to you, again, just reach out quickly to us at info@wrmeadows.com. Let us know you're interested in speaking with a rep, or at least getting contact information for your local rep, and we would be more than happy to share that with you so we can provide site support, procurement information, pricing, availability, and of course, assistance in any way that you might need assistance on your projects. So thank you so much. This concludes the presentation today. Thank you, Taylor, for such a great presentation. And all of you have a wonderful day. Take care.